So, what would happen if time froze for just 1 minute? Well, the answer is actually quite complex and it would depend on exactly how that minute unfolded. So, let's see if we can figure out a few scenarios together. First off, when we think about time freezing, we have to decide, does this mean only time freezes or does everything freeze? That is, does everything stop completely, including the laws of physics, and if so, what happens then? Let's start with the former. Timekeeping in general is something we humans do with clocks, which use various mechanisms like pendulums or quartz oscillators to vibrate at a consistent rate, defining a second by counting these vibrations. But atoms don't care about our arbitrary units. They just vibrate based on their own whims. And these atomic clocks are the most accurate clocks we have. We know that time would still pass in them because quantum mechanics says that anything that exists has a 50% chance of being in two places at once, meaning there's always a 50% chance that an atom will be somewhere else next. So even in the tiniest fraction of a second, atoms would still move. But would we notice this on a human scale? For some people, probably not. After all, the smallest noticeable blink of an eye is around 300 milliseconds. So, if time went down to 1/3 of normal speed for that 1 minute, we might not even notice. In fact, we already experience something similar every single year during daylight savings. When the clock strikes to AM on that one day, time briefly goes from 1 second to 4/3 of a second. And although we can't really feel that extra fraction of a second, it's measurable by instruments. So, why would time stopping for a minute be any different? Well, it would be very different for anything that relies on continuous motion. Take airplanes, for example. They need to keep moving forward to stay airborne. Even if they reflying at 60,000 feet up in the sky where air resistance ain't much of a problem, they still lose altitude over time due to the drag caused by the friction of the air molecules against the wings. This effect is called induced drag and it depends on the airspeed relative to the ground, not just the plane's own movement through the air. So, even though a plane could fly forever without losing altitude if it moved at the same speed as the wind, which is sometimes the case, planes have to keep speeding up just to maintain their altitude. And if time froze, those planes would rapidly lose altitude and crash to the ground. Or consider trains. For a train traveling at high speed, the wheels naturally skid a little bit on the tracks to compensate for the friction of the brakes, which pushes the train to a stop. So, if time were to freeze, the wheels would continue to skid while the brakes wouldn't be activated, causing the train to derail. Even the Earth itself would suffer if time stopped. Due to the conservation of angular momentum, the Earth spins on its axis with a period of roughly 27 days. And although this speed is so slow that we rarely notice it, it's crucial for life as we know it. It causes the Coriolis effect, which makes winds curve and influences ocean currents and weather patterns. It also affects the way stars and planets form, not to mention things like the shape of the Earth and its magnetic field. Basically, if time froze, the Earth would eventually slow down and stop spinning altogether, which would cause massive climate disruption across the entire planet. And that's just looking at things on the surface. If time froze in space, the sun and other stars would no longer generate energy, leaving Earth and the rest of the solar system in total darkness. And it gets even weirder when we consider gravity. According to Einstein's theory of general relativity, mass warps the fabric of spacetime, meaning the more massive an object, the greater the curvature of spacetime around it. The Earth curves spacetime enough that we naturally fall towards its surface. If time stops, the Earth would suddenly find itself in a universe with no gravity. The Moon, no longer bound to Earth, would float away into deep space. Oceans would boil and evaporate. Our atmosphere would dissipate into the vacuum of space. Without time, Earth becomes a lifeless hunk of rock floating in a dark, cold void. Okay, but what if instead of freezing time, everything froze, including the laws of physics? For this scenario, let's take inspiration from the movie franchise, where the main character travels back in time and accidentally kills a deer while saving his father as a child. As soon as that deer is killed, the protagonist realizes that everything seems frozen. He looks up at the sky and notices that the sun has disappeared, having been replaced by a massive black sphere. Turns out this is the result of the laws of physics breaking down at the moment he changed the timeline. Now, this idea of changing the past to save your father might sound familiar. You might be thinking of the famous Schrödinger's cat thought experiment in which a cat is placed in a box with a radioactive atom and a bottle of poison gas. Until the box is opened, the cat is both dead and alive, depending on whether or not the atom decayed. But when the protagonist shot the deer, there was no uncertainty. The deer was definitely dead. So this must mean that Schrödinger's cat was actually just a dead cat. This is the protagonist's conclusion after he returns to the present. But unfortunately, he finds that his new reality sucks. It's dystopian and everyone's dead. Maybe that's because time itself collapsed. A minute is a long time for a human, but in the grand scheme of things, it's an instant. So, if the laws of physics broke down, the entire universe would collapse in on itself within that minute. All of the planets would fall into the sun, the galaxies would spiral out of existence, and light itself would no longer travel. Everything would return to the state it was in just a tiny fraction of a second ago, creating a new universe, perhaps one in which cats are always dead. Now, all of this is just speculation, of course, because actually stopping time is impossible. Not only is it currently outside the realm of scientific possibility, it also violates our current understanding of the laws of physics. But maybe that's a good thing. After all, there are lots of problems in the world that are worth solving. But I don't think halting time would be one of them. I'm not sure about you, but I love time. Sure, it's responsible for the aging process and eventually leads to the heat death of the universe. But until then, it gives us the opportunity to do all sorts of stuff, like, say, subscribe to our channel. Hey, that sounded better in my head. Anyway, thank you for watching this video, and let us know in the comments what you want us to talk about next.